All right, I think we will get started. I'm sure a few others will join us. My name is Danny Cullenward. I'm the policy director with Near Zero, an environmental nonprofit that's based on the Stanford campus. I want to welcome you all to join us for our webinar today on an open source model of the WCI, the Western Climate Initiative Cap and Trade Program. Joining me today are my colleagues at Near Zero, Mike Mastrandrea and Mason Inman, who's the technical lead for this project. I'm going to give a little bit of an introduction about this project and our work, and then I'm going to turn it over to Mason, who will walk us through the features and functions of the modeling tool, which we distributed by email. I want to mention again, for those who just joined, this will be a recorded webcast. We're recording both the audio and the video for a number of people who won't be able to make this session, but we're hoping to view it later. So please be aware that your audio and video, if you turn that on, will be recorded. And so with that, let me turn to the function of the model. So I suspect that this group is quite familiar with the California and WCI cap and trade programs. The purpose of this particular project for Near Zero was to build a neutral accounting tool that can help us analyze, project, and track the various outcomes of relevance in the market. In particular, we're interested in the question of how the supply and demand balance in this program operates. And we're aware of a set of controversies around how that's played out in the regulatory process. This model is not meant to be a prescriptive tool that necessarily resolves all answers, but is rather intended to be a neutral accounting of the market rules as they exist. The basic philosophy of the model, as Mason will go into in a moment, is to have a transparent and accurate accounting of the system with minimized or hopefully next to no assumptions in the model code about what's going on in the market. Almost all of the variables of import are specified by the user, and the model basically calculates the supply side of the market outcomes, which allows people to explore a variety of scenarios around emissions under the program, as well as the supply of offsets and the performance of quarterly auctions. The purpose of our webinar today is to introduce the model and explain a little bit about how it works and provide a basic how-to guide for the web interface we've developed for it. We want to emphasize that the model code itself is open source and available for download, along with a fairly extensive documentation of that program. And the other secondary purpose of the webinar is to begin a process of gathering feedback from stakeholders and other experts in the market who will have a chance to review this work and provide any sort of feedback or comment both about the accuracy of the project to date, as well as potentially features that they're interested in seeing. The last thing I want to do is acknowledge our financial sponsor. We received a grant from the Energy Foundation to pursue this work. We're very grateful for their support, and we look forward to starting the conversation. So with that, I'll turn it over to my colleague Mason, who will walk us through the model and its development.
Great, thanks, Danny. Can everyone hear me okay? Well, I'll take that as a yes. So as Danny mentioned, everyone we invited to the webinar should have received an email yesterday with a link to our webpage where you can launch the model. But in case you didn't get that email or you haven't tried launching the model yet, then I'll show you how you can do that. So from Near Zero's homepage, then I'm going to go down to our report section where we have a new page up about the model and go to that. And there's a button, View Model, and that loads up the model in this service called Binder that we're using for hosting it, and it takes a minute or two to load up because it has to download and install a bunch of programs in order to make the model work. And then it will load up like this. And there's a secondary loading step, but this is what you'll see when you're using it. I'm going to switch to a local copy of the model for doing the demo here. So as Danny said, the model represents the supply-demand balance in the WCI cap and trade system. And our aim with this has been to represent the system as it actually is, based on the regulations that determine the rules for the program and using the historical data that reveals how the system has behaved in practice. So as for the regulations in California, the model is based on ARB's current regulatory proposal for implementing AB 398, the cap and trade extension bill that passed last year. And for Quebec, we're not aware of Quebec having made a proposal for changing its regulations, so the model uses their current regulations, which extend through 2030. The model code explicitly represents all the relevant facets of the regulations, such as how many allowances are available each year, how many get auctioned, and what happens to any allowances that go unsold at auction. And as for historical data, the model uses the latest data available for covered emissions through 2016, for auction outcomes through the third quarter auction this year, and offset supplies also through the third quarter of this year. And although a lot of the detail isn't shown in this interface, the model does inside represent the various accounts that can hold emissions instruments. That's both allowances and offsets. And it represents the movements of those instruments between the accounts. So, for example, when allowances sell at auction, then they move from government accounts to private accounts. And these are the same accounts that are shown in the compliance instrument report that ARB publishes each quarter. So we also ran the model in a hindcast mode, which attempts to replicate the historical data starting from the beginning of the system in 2012 and simulating it down to the detail of the quantities of allowances moving between the various accounts. And the model does replicate the historical record quite closely, so we're confident that it's working accurately. And as Danny mentioned in the introduction, our philosophy is that we wanted to make a neutral tool that would allow any of you to explore a wide range of possibilities. So people may disagree about what future outcomes are most likely, but with this tool, you can specify pretty much whatever scenario you'd like and see what the outcomes are. So to provide a starting point for that kind of exploration, we've built a default scenario that's based on historical results and on assumptions that ARB has made in its current regulatory package. I'll say more about those defaults in a few minutes, but first I'm going to just explain what's shown in the figure where you can see the main results from the model. So that figure is here, and this is results for both California and Quebec together. So in the left panel, the blue lines show the supply of emissions instruments that entered private accounts. So that includes both allowances and offsets. The dark blue line is historical data, and the light blue is a projection for the future. In this case, it's our default projection. The red and orange lines show the covered emissions. So again, that's historical and projected respectively. So these are not the total emissions in these jurisdictions, they're just the emissions that have a compliance obligation through the cap and trade program. So for California in 2016, for example, the covered emissions were 76% of the total emissions. So in any given year, if the supply of instruments entering private accounts is higher than covered emissions, then there's an excess of instruments that's banked. And on the other hand, if the supply entering private accounts is lower than emissions, then there's a deficit and any bank of instruments is reduced. The figure also shows the caps as a reference point. So the supply of instruments entering private accounts can be above or below the caps depending on whether some auctions don't sell out or whether the offset supplies are high or low, or whether there are unsold allowances from previous vintages that are being reintroduced and sold. So the figure here shows the historical record in which there was an auction collapse in 2016 and 17, in which about 140 million allowances went unsold at auction. Also, this year there's been a sharp increase in the supply entering private accounts, as many of those previously unsold allowances have been reintroduced and sold at auction. So that's the reason for this sharp dip and then the sharp increase that you see. In the figure's right panel, it shows the private bank of instruments in dark green. So again, that's both allowances and offsets. And on the right side, this is a cumulative view, whereas the left panel is annual data. So the right panel is showing the cumulative result of the supply-demand balance that's in the left panel. So in short, the private bank that's shown in the dark green is all the instruments held by private entities and which could be used toward compliance obligations incurred in the stated year. There's some nuances to what's in the bank, but you can open the box that's labeled about supply-demand balance in banking, which is above the figure. And it has more detail there, and it also a link to a research note that we published recently that has the full details behind this banking metric that we developed. The right panel also shows how many unsold allowances there were remaining in government accounts at the end of each year. That's in light green. So these are allowances that may be introduced to auction later. And if those sold at auction, then they would be added to private accounts and would count towards the bank. And the vertical line here is the dividing line between where we have full historical data for the supply and demand to the left of that line, and to the right, it's where we have partial or full, or where it's partially or fully based on projected data. So if a scenario would require sales from the reserves in order for emitters to have enough instruments to remain in compliance, then those reserve sales will be shown in red on this graph. There aren't any reserve sales in this scenario, but I'll show a scenario later in which there are some reserve sales. So now I'll go over the various drivers in the model that you can vary, and then we'll see how that affects the results. So first, there's the covered emissions. So I'll move down to that section. And so we have different ways of setting these settings, but I'll just start with the simple version first. So we have these sliders where you can change the annual percentage change in covered emissions for California and Quebec separately. So the default projection that we're using for both jurisdictions is that the emissions would decrease 2% per year. That default is based on the rate of decline in ARB's pathways model, which was used for the scoping plan. That model does not explicitly represent covered emissions, but and there are more details about this in the box below labeled about covered emissions, but we used it as a basis for choosing a -2% per year decline. And if you're interested in comparing the results of this model with other studies, I'll point out that this default emissions projection is very close to the projection that Chris Bush of Energy Innovation used as his mid-scenario forecast in his report on oversupply that was published last December. And it's also close to the emissions projections that the Environmental Commissioner of Ontario used in a report from this January about the WCI market. And to go back up to the figure briefly, I'd like to point out that in this default case with emissions decreasing 2% per year, then emissions do overshoot the cap in 2030, but emitters would remain in compliance with the program by using up some of the bank of instruments. So now we can look at another scenario in which the emissions are lower. So I'll change this setting to -3% per year, and then go back up and run the model and see how the results come out. So now the line has shifted down, and the emissions in 2030 are about the same as the cap. But all the years prior to that, the emissions are lower than the cap and lower than the supply of instruments entering private accounts. So there is banking that's occurring every year up to 2030. And so you can see that banking in the right panel where the bank continues to go up and up through 2030, reaching about 600 million tons. That's about twice what it was in the default scenario that I showed a minute ago, when the bank was about 300 million tons in 2030. So now we could look at another scenario in which emissions are higher. Perhaps they only decline 1% per year. So I'll shift those. And I'll run it again. And this time, the emissions go well over the cap in 2030, and the bank of allowances gets used up toward the end of the model period. And in 2030, there would have to be some reserve sales in order for there to be enough instruments in the system for emitters to remain in compliance. In this case, it's nearly 50 million tons of reserve sales that would occur. So if you want to specify a different kind of emissions projection, say one that goes up and then goes down, or with a rate of change that varies over time, then there are other options. There's an advanced option and a custom option, which give you more control. In the custom option, you can paste in data to specify any emissions projection that you want. So next, I'll go to the auction settings, and so to see the effect of just the auction settings by themselves, I'll put the emission settings back to the default, and then go on to the auction. So for the auctions, our default scenario is that all future auctions will sell out. So if you want to specify a different scenario, you can do that with the Advanced tab, which I'll click on here. And so the projection starts in 2019 because we already have data for 3 of the 4 auctions in 2018, and the model assumes that the last auction this year will sell out. And then you can specify years in the future in which the auctions do not sell out, and then you can specify the percentage that go unsold in those years. So for example, you could simulate an auction collapse similar to the one that occurred in 2016 and 17. And so I'll choose that maybe there would be this kind of collapse in 2022 and 2023, and that the percent unsold would be 50%. So then I'll move back up to the figure and run the model again so we can see the results. So then it takes a little while to run the auctions because there are a lot of complicated rules involved when some allowances go unsold. And although the auctions are held jointly in the model for making the code easier to read, the auctions are calculated separately, so that's why it has separate progress bars for the 2 jurisdictions. So the rules for the auctions include that once 2 auctions in a row sell out, then unsold allowances can be reintroduced, but only up to a certain limit. And with California's allowances, if they remain unsold for 24 months, then they get transferred over to the reserves. So we've implemented all of those auction rules in the model code for determining what happens when there are some auctions that don't sell out. So now that it's finished processing, we can see that the outcome for the scenario in which 50% of allowances go unsold in 2022 and 2023 is that the supplies entering private accounts shown on the left panel, they dropped down a lot in those years because there weren't as many allowances sold. But then in the subsequent years, the supplies entering private accounts shoot up above the cap because the unsold allowances, many of them are reintroduced and sold at auction. So the result in this scenario is that at the end of 2030, there's still about 175 million instruments in the bank. So this auction collapse would have a significant impact on the size of the bank in 2030, but it wouldn't completely wipe out the bank. So next, I'll turn to offsets to show the settings for that. And and I'll return the auction settings to their default. So I'll go back to the simple tab here for all auctions selling out, and I'll point out here one way that the model works is that whichever tab you have open at the time when you hit the run button, those are the parameters that will be used in that model run. So now that I've gone back to open the simple auction settings, when I do a new run, then it will use the assumption that all auctions sell out. So for offsets, the offset projection starts in 2019 because we already have data for offset sales for most of 2018. And through 2020, California and Quebec both limit offset use to 8% of the limit of the instruments that are submitted for compliance. And so far, the historical data shows that offset supplies have been about 75% of the limit of what could be used. And also, ARB assumed in the current regulatory package that offset use from 2021 to 2030 would be 75% of the limits in those years. So in those years, California will be using lower limits on offsets, whereas Quebec is going to continue with the 8% limit that they have right now. But because the historical data and ARB's assumption both had supplies in use at 75% of the limit, we use that as the default for our offset supply. But if you want to specify a different degree of offset supply, you can move this slider between 0 and 100%. So 100% would mean that the supply in these years is equal to the limit of what could be used. And if it's 0%, then that means there will be no more offsets added to the supply for those years. So I'll set it to 50% and we can see what kind of impact that has on the results. So I'll go back up here and run the model again. And in this case, the bank in 2030 is reduced to about 235 million tons. And so that's a reduction of about 20% compared with the default case. So having lower offsets here does have a significant effect, but again, it's not enough to wipe out the bank that you have in 2030. So those are the main ways that you can modify the auction or the model results. And I'd like to just point out a few other features of the model about how to use it. If you want to save the results that you've gotten from a particular run, you can use this button here, Save Settings, Save Results and Settings, and it will give you an Excel file which has the data in the graphs, and it also has a little table of the settings that you've put in. And if you want to save the figures, you can use this Save button over here below the figures, and it will open up a window to save each of those plots. It may be that the model will time out, where if you leave it without doing anything with it for a while, then it will stop running. Or if you run into some other kind of problem where it's not functioning properly, you can go down to this button at the bottom where it says refresh entire model and to get it working again. But if that doesn't work, you can always go back to the report page for our model and load it up from the link there. So now we'd like to open it up for questions about anything that you're interested in, about details of the model or how to use it or the policy implications. And so if you're on the computer, then you can unmute yourself with pressing the unmute button on the toolbar. And if you're using the phone for audio, then *6 to fix.
And we open it up. I actually want to point out one important assumption in the model for folks who are watching this. And Mason, I wonder if you could pull up a scenario that uses the reserve accounts, so a high emission scenario. One of the key features of this model is the model doesn't make any assumptions about prices or demand that's price induced. There's no relationship economically between the projected emissions and the timing or use of the particular instruments that are involved. We assume for convenience that the existing supply of allowances in the private bank is drawn down to zero before reserve sales are used. Now, this is not a projection of what we think is most likely. If the reserve, including the so-called price containment points that are set in between the price floor and the price ceiling, are accessed, it's likely they will be accessed before all of the allowances in private banks are consumed down to zero. Nevertheless, because we didn't want to make assumptions about when particular accounts would be accessed, we used this particular version that is, you can think of sort of a worst case scenario, or the latest that price reserve accounts would be accessed. And so for this particular scenario, we are not saying, and the result should not be used to imply that no reserves will be accessed until the year 2027. That's not at all how to interpret this. What this is saying is that on a cumulative balance, approximately 300 million reserve allowances would be needed for this particular emission scenario to achieve the orange line on the left-hand side of the figure. And it doesn't tell us, or at least it doesn't reliably tell us when those would be accessed. This is the latest they could possibly be accessed. So I just wanted to flag that for people because we don't project prices, and this is one area of translating the sort of supply-side engineering of the market into prices where there's a discontinuity between our approach and the likely price implications of any particular scenario. So with that, I'd like to open it back up.
This is Chris. Chris Bush. I just wanted to thank you all for doing this work, and it looks fantastic and very clear, and looks, nice user interface. So thanks so much for automating this for the benefit of everyone. Is it possible? The one thing I may have missed it, but is it possible to see sort of how many of the previously unsold are diverted into the reserve due to going past the 2-year time threshold for remaining unsold and in the queue to be resold?
Sure, yeah, that's not, it's not shown on here, but it's calculated in the model. And so the amount that it calculated was 38.2 million that would get transferred and not be available for reintroduction. And so if people are interested in that or any other aspects of the model, but they don't want to try and get it running themselves, then I'm happy to help out by sending results. I can send a kind of complete set of results of the model and tell you how to make sense of them, or if you're wondering about a particular thing, I can pull out those results and send them to you. And if you have ideas about various things that we could show on the interface too, then we're welcome to hear ideas. And so I could add more graphs below that show how many allowances are getting reintroduced and sold, how many are getting taken out of the normal auction supply, and so on.
Great, thank you.
Other questions? We welcome any input, feedback, questions for future issues. Let us know. As a question maybe for the group then, I wonder if anyone on the webinar was able to launch the model themselves, just to check in to see if anyone was able to use this interface on their own through the web link at our website.
I haven't got around to it quite yet, Danny.
All good. Well, it is available. And again, the interface on our website is the viewer that Mason has walked us all through. The underlying code and the documentation is also available for people who are interested at anywhere near that level of detail. It's all public. But again, I think the purpose of the interface was to make this easy for folks to use without any coding background or experience, just a little bit of web interface.
So it looks like coming out of the first compliance period after 2013, 2014, the bank is, in your estimation, well, it's definitely less than 50 million metric tons, correct? Is it 30 there, or what is the amount after, at the end of the first compliance period?
Mason, do you have that information?
Yes, sorry, I was on mute. It is 31 million metric tons. So if you want to see some of the details of those exact numbers, then you can use the button down here, Save Results and Settings, and then it will show you the exact numbers for each year.
Great. Any luck having a dialogue with the Air Resources Board about these topics?
I think I'll let Danny handle that one.
Sure. I think the first thing to say is that we intend this model to be a tool where people can explore different points of view. And so this is quite literally our first public presentation of it. We put out the source code and the interface yesterday. So we've not had any direct engagement on this issue, at least with this particular project. And I think that's something we would be very interested in, and more importantly, to build a common factual understanding of the market conditions and to receive feedback again if there's something about the way the model has represented the regulations that needs to be modified. The goal is for this to be a neutral accounting and not a prescriptive tool. And I think its highest and best use would be for stakeholders of multiple perspectives to agree on the basic facts in the program without necessarily the tool itself implying any particular judgment about that. So obviously, I think many people on the call know that Near Zero has been critical of this issue of oversupply. We will continue to express our views about that matter, but the point of this tool is not to be a direct part of that argument so much as a tool that anyone can use, again, with the goal of building a shared factual foundation. I'm going to answer a few questions I've gotten in writing. A member of the webinar asks if it's possible to load the model with a different emission scenario, for example, from the pathways model that ARB uses in the scoping plan process. And yes, I just want to affirm for everybody that the covered emissions input to this has a custom tab, which is the third tab on the right. You can see it at the very bottom of the screen right now. And that tab allows you to put in any annual series of emissions you like. And so it doesn't have to be, we have these default sliders to make it simple and intuitive, but you can put in any custom scenario you like, and it doesn't matter the source. It's just a series of numbers. Another question about the instrument supply, what it equals. The supply of instruments is the combination of allowances and offsets. And the allowances include both allowances that are freely or directly allocated from the participating governments to private entities, as well as the allowances that are auctioned. And again, the mechanism of the model is to track the ability to have different scenarios for those auction outcomes. And I think those are all of the written questions so far. We would welcome any further questions from the audience.
Yeah, and I'll just add a little bit to what Danny said. It's the supply that's entering private accounts. So if there are allowances that go unsold, then they don't count in the year that they go unsold. But if they get reintroduced and sold, then they count in that later year.
And I will add, Mason didn't walk through this, but for most of the pieces of the model, the different 3 sections of inputs, there's a little explanatory tab you can expand that provides additional information at a high level. And in addition to that information, it links to several reports we've written. In particular, a report we put out a couple of weeks ago on tracking banking in the WCI system, and that includes the full technical details of how we measure these material in our empirical metric, and the concepts that we've used in the model from similar data sources. But again, obviously the model is projecting forward and not using the empirical data for future years. We would be delighted to stick around and chat with anybody by text or audio here. But hearing no further questions, I want to thank everybody for their time and for input in the future. We welcome any comments people have. Again, this project was led by Mason Inman, who's the technical lead, collaboration with myself and Mike Mastandrea from Near Zero, with funding from the Energy Foundation. And again, we'll stick around. We'll be happy to continue talking with folks, but we want to thank everybody for their time and engagement.